Okay, let us continue to study this. The absolute value of this integral is less than the integral of the absolute value of this. So we take the absolute value of the integrand, and this is oscillating factor modulus 1, exponential minus IR cosine theta t disappears. That is just 1. And real part of the over factor is a minus I. So minus r sine theta t. Minus r sine theta t. Integration over theta from 0 to pi. We know this sine function is symmetric from 0 to pi. This part and this part, these two curves are the same. So integral over theta from 0 to pi is the same as the factor of 2, double the integral from 0 to 1/2 pi. And we can find the upper bound of this integral. That is just sine theta is replaced by 2 theta over pi. The reason is like that. If we draw a straight line from 0 to 1, that is the maximum value of sine theta at 1/2 pi. So the straight line can be parameterized by 2 theta over pi. Alright? And because this is straight line and the sine theta is always greater than the 2 theta over pi from 0 to 1/2 pi. Therefore, exponential negative sine theta is always less than exponential minus 2 theta over pi. Alright? So this guy is an upper bound of this integral. Now we can integrate the theta out. The value of the final result is pi over RT, 1 minus exponential minus RT. This guy, as r goes to infinity, this guy goes to 0, and the first term goes to 0, whether t is positive or negative. However, if t is negative, this exponential factor blows up and the whole integral is not finite. So, only if t is positive, this value goes to 0. Okay, so when t is positive, upper bound of the absolute value of this integral approaches 0. Therefore, this integral vanishes. So, only if, I don't know what happens to the case t is negative, but that does not constrain the integral is finite. Only if t is positive, we can say this integral along the lower half plane, along a semicircle, vanishes. Therefore, we know that this integral on this lower half plane is 1, and this guy is 0. Therefore, if t is positive, integral from minus r to r, as r goes to infinity, is 1. So if t is positive, this real integral along a real axis is 1. Now we consider the case if t is negative. In that case, we just choose upper semicircle to test. The whole integral along the c plus contour, closed contour, was 0. And we would like to show that the integral along the upper semicircle vanishes. In that case, the integral from minus infinity to plus infinity is 0. So if t is negative, we can parameterize the omega on the upper semicircle as omega equals r exponential I theta, where theta runs from 0 to pi. And in the same way, according to the same way, we can rewrite this absolute value of the integral along the upper semicircle to be like that. We just copy everything except that cosine theta minus sine theta, that is exponential minus I theta. I used exponential plus I theta for parameterize the path along the upper semicircle. So I have plus I sine theta, and I do the same way to get the upper bound of this integral. Alright, so I take the absolute value of the integral, that is the same as this, except that I have positive sign, minus I plus I, positive sign r, t sine theta d theta, and again we can double the integral from 0 to 1/2 pi and so on. And finally this guy is, because t is negative, this guy, just like this integral, vanishes as r goes to infinity. So we have shown that the integral along the upper semicircle vanishes, and finally the integral from minus infinity to plus infinity is 0 if t is negative. In summary, again, the integral from minus infinity to infinity, this integral is exactly the same as the contour integral on the lower half plane, because the integral along this lower semicircle vanishes, and that is 1 if t is positive. If t is negative, the integral along the upper semicircle vanishes, and regardless of the value of the t, the closed contour integral on the upper half plane vanishes. Therefore, this integral, I over 2 pi, integration of omega from minus infinity to infinity, exponential minus I omega t divided by omega plus I epsilon, as epsilon goes to 0 plus, is theta function.